شخصية ولا بريان هو أتذكر واجد بس
是
Assalamu alaikum wa rahmatullahi wa barakatuh. My dear student, we are going to explain chapter 11 because gear section stop at chapter 11 and so we'll complete with gear section. Okay, the first lesson in chapter 11, making ammonia. Now we are going to explain this lesson, making ammonia. Making ammonia, the symbol of ammonia is NH3. Okay, the major process used for making ammonia is called Haber process. So Haber process is the process that used to making ammonia. Ammonia is mainly composed of two elements, nitrogen and hydrogen. Nitrogen and hydrogen. Okay. Ammonia mainly composed of two elements, nitrogen and hydrogen. Source of nitrogen. How to obtain nitrogen for this process? The nitrogen used for this process is obtained from atmosphere by fractional distillation. Fractional distillation. We know the fractional distillation, the base idea of fractional distillation, the melting, the boiling point of elements. Okay. Again, how to make ammonia? Okay, by using process called Haber process. Haber process. This process used two elements, nitrogen and hydrogen. So the mainly component of ammonia are hydrogen and nitrogen. How to can obtain nitrogen for this process? By fractional distillation of atmosphere air. Okay. Next, source of hydrogen. The second element here is hydrogen. How can obtain hydrogen for the Haber process? From reaction between methane and steam. What's the meaning of steam? Steam means water vapor. Water vapor. Okay. The reaction here, methane react with steam. This means reversible reaction. Produce hydrogen and the carbon dioxide, the carbon monoxide. Again, the source of hydrogen for Haber process. Number one, from reaction between methane and steam. Okay, methane will react with steam, produce hydrogen and the carbon monoxide. This equation represented by symbol as the following: CH4, this methane, plus H2O, water, produce 3H2, hydrogen, and CO, carbon monoxide. Again, the source of hydrogen for the process called Haber process. What's the meaning of Haber process? Haber process is a process that used to produce ammonia. Ammonia is a compound composed mainly of two elements. Number one, nitrogen. Number two, hydrogen. How to obtain nitrogen? By process called fractional distillation of the atmosphere. Second, how to obtain hydrogen from process the reaction, number one reaction between methane and steam. Produce hydrogen and the carbon monoxide. This process carried at temperature 750 degrees Celsius to number two, pressure of 30 atmosphere and catalyst of nickel. So this process need catalyst to achieve this process. What's the meaning of catalyst? Catalyst is a chemical substance enter the chemical reaction to increase or decrease the reaction, but don't change. Okay, catalyst mean again. What's the meaning of catalyst? Catalyst is a chemical substance enter the chemical reaction to increase or decrease the reaction. Without a change itself. Okay, so here this process reaction between methane and steam need catalyst. Our temperature at 750, pressure at 30 atmosphere, and the catalyst of nickel. The carbon monoxide produced from the reaction reduce some unreacting steam and produce excess hydrogen gas. This is represented by the following equation: CO, carbon monoxide, plus H2O, excess steam, produce gas hydrogen, H2 plus carbon dioxide, CO2. Okay? This is the first point in this, the first point of this lesson. We will explain it again. Listen to me carefully. Making ammonia. The symbol of ammonia is NH3. The major process used for making ammonia is called Haber process. Okay, this process, the ammonia is composed of two elements. Number one, nitrogen and hydrogen. How to can obtain nitrogen for this process? By making fraction distillation for atmosphere. The source of hydrogen used in this process is obtained from number one, reaction between methane and steam. Methane and steam. The steam here is water vapor. When methane reacts with steam, produce hydrogen and carbon monoxide. This reaction needs catalyst. This catalyst called nickel. Okay. What does this mean to irreversible? This means reversible reaction. This process carried out at temperature 750 degrees Celsius, pressure 30 atmosphere, catalyst of nickel. The carbon monoxide produced from this process can react with excess of unreacted steam to produce excess of hydrogen gas and carbon monoxide. I will ask you any question. Any question for this point? If you want to ask a question, please raise your hand. To ensure this point are satisfied for you. Anyone don't understand this point? If you don't understand this point, please raise your hand. That's okay. The next point in the process, our process, this is very important. The proportion of nitrogen to hydrogen. The proportion of nitrogen to hydrogen is 1 to 3. The proportion of nitrogen to hydrogen is 1 to 3. The pressure approximately 200 atmosphere. A temperature of between 350 degrees Celsius and 500 degrees Celsius. The catalyst is finely divided iron. So we can differentiate between the catalyst used to making ammonia and the catalyst used to obtain hydrogen. In case of hydrogen, we need nickel, but in case of ammonia, we need divided iron. Nitrogen, when nitrogen reacts with hydrogen in presence of fine iron, ammonia produced. Nitrogen N3 plus 3 hydrogen gas, H2. Reversible, this means reversible reaction. Produce ammonia NH3. This reaction delta H equal minus 92. What's the meaning of delta H? Delta H means this reaction is exothermic reaction, produce heat. This reaction means exothermic reaction. When the delta H equal negative, this reaction means exothermic reaction. Now, this is the experiment to make ammonia in lab. Now, anyone don't understand making ammonia by process, Haber process? If you don't understand, please raise your hand. Okay? All of you understand this process? Okay. Now, the second point, making ammonia in lab. making ammonia in lab. By simple process, listen to me carefully. Look at this picture. Small amount of ammonia gas can be produced by heating any ammonia salt. Any ammonia salt, for example, ammonium chloride. For example, ammonium chloride. Ammonium chloride. With alkali, calcium hydroxide. Now, put in this cylinder ammonium chloride and calcium hydroxide and apply heat. Okay, and apply heat. The production of this reaction produce calcium chloride plus water plus ammonia. Again, calcium hydroxide. It is alkali with ammonium chloride, salt of ammonia, produce calcium chloride plus water and ammonia, making ammonia in lab. Very simple experiment. Put ammonium chloride with calcium hydroxide and apply heat. Okay, the reduction here is calcium hydroxide, calcium chloride still in the cylinder, and ammonia gas evolved in this opposite cylinder. Okay, this equation can be represented by the following symbol: CaOH2 plus 2NH4Cl produce, in presence of heat, produce CaCl2 calcium chloride plus 2H2O water plus N2NH3 ammonia. So we can obtain ammonia in lab by easy experiment by reaction between ammonium chloride with weak alkali calcium hydroxide in presence of heat. Okay, calcium hydroxide will react with ammonium chloride with thermal effect. Calcium chloride and water and ammonia are produced. This point is clear. If anyone don't understand, please raise your hand. All students are. Yes, Salman, ask your question. Salman, yes, ask your question.
Sir,
Yes.
Mr. You're only reading all of this, Mr. Like, explain why.
Again,
why,
again,
like,
I don't hear your question again.
Mr. You're only like reading the what you have written. Can you explain, for example, why 350 degrees Celsius is required?
Why?
Mr. Why 350 degrees Celsius is required for the previous reaction? Why everything? Like, why this much temperature and why You're just reading it and telling us that this is this.
Your question, why use this high temperature and high atmospheric pressure?
Yes.
Yes. Listen to me carefully. The experiment don't apply at once. We have to make this experiment by more trials. Okay? As the first, we need the low temperature and low atmospheric pressure. Okay? There is no products in this case. And raise the temperature and raise the pressure. There is no product. And so raise and raise until reach my result. Okay, understand? So if you want to make any trials for your life, okay, you are make many trials to ensure to gain this you achieve. You understand? So we reach this result by many trials. Reach this result by many trials. Okay? No at once. You understand? Anyone have any question? Okay. The second point, physical properties of ammonia. Physical properties of ammonia. Number one, ammonia is colorless. Number two, ammonia less dense than air. Less dense than air. Number three, ammonia has pungent smell. Number four, ammonia very soluble in water. About 680 cubic centimeter of ammonia dissolved in each 1 cubic centimeter of water. Again, ammonia is very soluble in water and produce ammonium hydroxide. Very soluble in water. About 680 cubic centimeter of ammonia can dissolve in each 1 cubic centimeter of water. Okay? Again, physical properties of ammonia. The physical properties of ammonia, number one, colorless. Number two, less dense than air. Number three, has pungent smell. Number four, very soluble in water. About 680 cubic centimeter of ammonia dissolve each 1 cubic centimeter of water. The chemical properties of ammonia is very important. Listen to me carefully in this point. Number one, thermal effect. How the heat affect ammonia? By applying heat on ammonia, produce nitrogen and hydrogen. This reaction is called reversible reaction because when nitrogen reacts with hydrogen, give ammonia. But when you apply heat on ammonia, it produces nitrogen and hydrogen. This equation represented by 2N3 ammonia by effect of heat produce nitrogen N2 and 3H2 hydrogen. So thermal effect by applying heat on ammonia, this will the product nitrogen and hydrogen. Reaction with acid. Ammonia when react with acid produce salt. Okay, ammonia when react with acid produce salt. The example here, ammonia when react with hydrochloric acid, the production is ammonium chloride. When the ammonia react with hydrochloric acid, this reaction produce ammonium chloride. This equation represented by NH3 plus HCl produce 2NH4Cl, NH2NH4Cl, ammonium chloride. Again, the reaction between ammonia and acid produce salt. The example, ammonia react with hydrochloric acid, produce ammonium chloride. The third properties, solubility in water. Solubility in water is very important point in this lesson. Listen to me carefully in this point. Solubility in water. This experiment called Ponin flask experiment. Ponin flask experiment. Okay. Look this picture. The step of this experiment, look at the picture here. Fill a large beaker with water and universal indicator such as phenolphthalein. Add concentrated ammonia to the flask. This is concentrated ammonia in this flask. Boil the ammonia. As a first, boil this ammonia before put it upside down. Boil the ammonia solution. Place the flask upside down with straw in the water, like in this figure. Okay, observation. At the first, the pressure in the flask and outside are equal. As the flask cool, the gas pressure push down the straw. Okay, push down the straw on the water drop, and the air pressure push the water slowly up the straw. Again, here in this beaker, put water and universal indicator like phenolphthalein, and in flask put concentrated ammonia. And before put this in this position, boil the ammonia solution. Place the flask upside with straw inside the water. Observation, what we can see, at the first, the pressure in the flask and out are equal. As the flask cools the gas, the pressure pushing down the straw on the water drops, and the air pressure push the water slowly up the straw. Once the water reaches the flask, ammonia quickly dissolve in water, and the experiment air pressure push the water up straw, result in ammonia fountain. This is called ammonia fountain, and to convert to purple color. We know the ammonia is colorless. By the action with water, convert to purple color. The solubility of ammonia can be represented by the following equation. Ammonia plus water produce ammonium ions and hydroxide hydroxide ions. NH3 plus H2O produce NH4 plus OH ions, positive ions in NH4 and negative ions of OH. The solution is only weak alkaline because of the reversible nature of this action. The solution which is produced in this case after ammonia react with water is a weak alkaline. Okay. Aqueous solution and form what's called aqueous solution. When the ammonia gas dissolved in water, form aqueous solution of ammonium hydroxide. Aqueous solution can be used to identify salts of metal ions, like in this table. If anyone don't understand the experiment, please raise your hand. Again, Shah. Yes, Shah.
Yes, again, please explain.
Again. Now, listen to me carefully. In this beaker, put some of water and the universal indicator. Okay?
Okay.
Add concentrated ammonia to the flask. Before put this flask in this position, boil the concentrated ammonia. Place the flask upside down with the straw in the water. To put this straw in the water. Observation at the first. What happened? The pressure inside the flask equals the pressure outside the flask. Why? Because the gas, all the ammonia gas, occupy all of the flask. There is no space here. After the gas cool inside the flask, this give a space to the drop of water to go up. Okay, when the drop of water go up to the flask, it reacts with ammonia here and make this phenomena ammonia phenomenon like this in this case. Once the water reaches the flask, ammonia quickly dissolves in water, and then the external air pressure push the water up when the straw result in ammonia phenomenon. Why this? Why the ammonia give this color? Because in case of phenolphthalein, when react with alkaline, it changes to purple color. We know the ammonia when dissolved in water, it gives weak alkaline solution. When react with universal indicator phenolphthalein, it gives purple color. Understand?
Yes.
Any question?
No.
Thank you. Anyone else understand the experiment? There is a video in the last of the lesson explain this experiment. Reaction with oxygen. The last chemical properties of ammonia, reaction with oxygen. Ammonia is not a supporter of combustion and doesn't burn in air. Ammonia can burn with oxygen in presence of catalyst. Ammonia can burn with oxygen in presence of catalyst, like platinum. This reaction can be represented by the following equation: ammonia plus oxygen in presence of catalyst platinum give water and nitric oxide. This equation represented by the following symbol: NH3 plus 5O2 in presence of catalyst platinum produce 6,2H2O water and 4NO nitric oxide. This is the end of our lesson. Anyone don't understand this lesson, please raise your hand to explain anything for you. Yes, share. Yes, Muhammad. Okay.
You have likely produced ammonia in the laboratory.